Physical Science Exam 2015, and this is the first of the Criterion 6 questions. So this will be question 7. Complete the nuclear transmutation equations shown below and identify the type of decay. So what we have here is, we can look these up on our information sheet. And look on the back page there. You know what these are, boron anyway. Boron is right there. The number of protons, the atomic number is 5. And in this case, the number of nucleons, or the mass number, is going to be 12. Remember that on the information sheet, we've even got boron up the top here, how convenient, that the relative atomic mass is down the bottom and the atomic number is up the top, which is different to what we have in traditional writing. So what we have here is something's going on here, so that in boron it's changed into lithium plus something. We don't know what's going on, but we can check out what's happening here. This is the number of protons. It's giving up, so these are going to add up to 3 and 2 are going to add up to 5, this number of protons, and there's going to be 8 plus something equals 12, and it's going to be 4. And if we go and have a look at our, if we don't remember, then down the bottom we have of the second page, page 2, we have our nature of radiation. We can see that an alpha particle is a helium nucleus which has 2 protons and 4 nucleons, so 2 protons plus 2 neutrons. So we can call that an alpha particle. Plus there's going to be energy released. What type of decay is that going to be? It's going to be an alpha decay. Cool. Right. We can look up here, number 91, PA. Come back to our information sheet, and we go to 91. Here we go. Protactinium, good old protactinium. Now, what's happening here is this is in a meta state, which means that this is being chock-a-block full of energy, and it has to give off some of the energy. And how's it going to give off? Well, it's going to be unchanged in terms of the number of nucleons. So what we're going to do here is the only way that we can give off energy, and that energy is going to be in the form of gamma radiation. What type of radiation is that going to be? It's going to be gamma radiation or decay. Remember that gamma is just going to be excess energy, so it just gives off excess energy, just electromagnetic waves here. So there's no change in charge, there's no change in mass, it's just going to give off some energy. So if it goes from that case to that case, it's just going to give off gamma radiation. When nitrogen-14 in the atmosphere is bombarded with cosmic radiation, carbon-14 is produced along with a proton. So nitrogen-14 gives off carbon-14 plus a proton. Write an equation for this reaction and identify the cosmic radiation that causes the reaction. So nitrogen-14 is bombarded with something we don't know, and it's going to produce carbon-14 along with a proton. So let's have a little look here. Well, we know what a proton looks like. A proton is going to be a charge of 1 and a mass of 1. So we can have a look at that. Let's go back to our periodic table, and that should help us out in this case. Carbon, 6 protons. Nitrogen, we need to find out, if we don't know already what they are. Nitrogen-14 has got 7 protons, so it's got nitrogen 14, and we know that nitrogen by definition has 7 protons, so that's going to be like that, plus something, we don't know what it is going to produce carbon. Now carbon has 6 protons, carbon-14, plus, write the equation of this reaction, identify the cosmic ray. So what else is there? Producing a proton, and a proton is going to have a mass of 1. It's going to have a 1 proton there, and the mass is going to be 1. So that's what's going to happen there. So what we need to do is to work out. So that's what's going to be formed, and there's something that's going to make these up. We have to make these balanced. 7 and 7, so it's going to have a 0, and 14 It's going to be 15 here, so it's going to have 1 up there. Now, what has a mass of 1 and a charge of 0? Well, let's have a look back over here. I think I know what it is already. But let's have a little look on the information sheet to see where we can get this information. Mass of 1, charge of 0, it's going to be a neutron. Name of the cosmic radiation is going to be a neutron. And there you go. 4 marks.